So today we are going to be looking at the derivation of Newton's second law of motion. So just a quick reminder of what Newton's second law actually states. So according to this law, the force acting on a body is directly proportional to the rate of change of linear momentum of the body, and the change in momentum takes place in the direction of the force. So let me just numerically write this formula. What we actually say is force is directly proportional to the rate of change of momentum. Okay, so let's just break down this formula. First off, let's look at delta P. Okay, delta P. So before that, since this is delta P, we need to be knowing the final as well as the initial momentums actually. Both the initial as well as the final linear momentums should be required in order to prove, in order to show, or in order to derive delta P. So for that, let me just first write this down. So initial momentum, which is mass times velocity, as you know, momentum is mass times velocity. I'm writing mu because u is initial velocity, and then I'm moving further. I'm writing pf, which is final momentum. Mv, you know, v is the final velocity. So let me just declare this as equation 1, and this as equation 2. So let me just compare both of these equations. So if we compare both of these equations, we end up with delta P, and then PF minus PI. Why PF minus PI? Because naturally let's just assume that PF is greater than PI. But say PI is greater than PF, then we need to be writing PI minus PF. But let's just assume PF is more than PI. Okay, so we just stated that PF is MV, and PI is MU. Let's just substitute that MV minus MU. So then I take M as common, V minus U, and well, let's just declare this as the third equation. No space there, but then yes. Okay, so we've just we've just said that delta P is equals mass times velocity, that is final minus initial velocity. So let's just get back to the formula again. Force is directly proportional to delta P by T, which is the rate of change of momentum. So we just said from equation 3 that delta P is mass times V minus U, which is final minus initial velocity. Let's just substitute it there. F is directly proportional to mv minus u by t. In order to remove this proportionality symbol, we use the universally accepted constant k. Just write it down, and the value for k is 1. In all systems it's the same. So okay, if we apply it, we end up with this. Just write it right. F equals k m v minus u by t. With that, since k is 1, we can just neglect it. We get m v minus u by t. Does this sound familiar? Well, we can also write this as m v minus u by t. I mean separately because it's in multiplication. Well, what is v minus u by t? It's acceleration. So finally we have successfully proved that force is nothing but mass times acceleration, and this time we did it with Newton's second law of motion.